Okay, welcome to chapter 5.1. Chapter 5 is all about percents, ratios, and rates, and we're going to start with percents. In this lesson, it's actually 18 pages long, so it's a really long lesson, so I'm going to cut it in half. Relating fractions, decimals, and percents, I guess the basic way of saying it is you have to be able to take any one of those three things and be able to convert it into the other two. So you have to be able to go from fractions to decimals, fractions to percent, decimals to fractions, decimals to percent, and of course percents to fractions, percents to decimals. That may sound simple, but with mixed fractions, improper fractions, repeating decimals and stuff like that, it can become a little bit more complicated. This lesson was originally 18 pages long, and I found that's way too long. So what I've done is I've chopped it in half. We're going to go halfway through this lesson, and then we're going to stop and do the assignment on that half, and then we're going to move on to the next half, okay? So let's get started. It says, before we begin, I want to go back and just do some very basic reviews, just to prove to you that a percent, a decimal, and a fraction are all the same, are all equal, and each one of them is basically stating the same thing. So take a look at this box here. I've got 3 shaded out of 6. So if you take a look, that's 3 over 6, or 3 out of 6, and this can be reduced by dividing the top and the bottom by 3, and that will give you 1/2. Now if you take a look at it as a decimal, 0.5 of the boxes are shaded. That's 1 divided by 2 if you wanted to go it that way. And of course, as a percent, we know that 50% of the boxes are shaded. Since the boxes are all, since the box does not change, and it's equal to 1/2 as a fraction, it's also equal to 0.5 as a decimal, and it's equal to 50%. That means that this, and this have to be equal. So our job is to be able to convert back and forth between all of them. So if we start with some of the basics first, fractions, I've got a simple basic fraction here. The top is called the numerator, and the bottom is called the denominator. When we go to a mixed number, or a mixed fraction, we add simply just the whole number in front of it. The numerator and the denominator do not change names. So we're going to be using those things as we go. So our first lesson, our first part is actually called converting fractions to decimals. The first place to start, so a fraction is another way of writing a divide question. I've shown you this in class many times. If I gave you 1 over 2, it's very similar to a divide question. You just take a look like that. You'll find that the fraction is actually kind of looks like a divide sign in a way. So how do we make it actually become a decimal? Well, to do that, you basically, I'm using basically too much, you take the numerator and you divide it by the denominator. So for this one, it's going to be 3 divided by 8. Now you're going to be allowed to use your calculator. So what you get is 0.375. Now remember, you have to show me what you did and what you got. You can't just have 0.375 appear out of nowhere. So the next one is 6 over 8. Well, 6 over 8, you do the same process. Numerator divided by the denominator, and that gives you 0.75. Now this works really good if the actual fractions terminate when they're in decimal form, but sometimes they don't. If we try this one here, you get 1 over 3. If you divide it, your calculator is going to show you 0.333333. So this is what you'd be looking on what you did, and of course your calculator is going to fill the screen with 3's. Can't write down 0.33333 10 times every time we want to work with this, so we have to have a shorter way of writing this. To do this, we have to find the part that repeats. In this case, it's right here. That is the part that's repeating. The repeating decimal part will sometimes be 1 digit. It can be 2, it can be 3, 5, sometimes even higher than that. But for this particular one, it's just 0.3 repeating. So you write it with a bar over top of the part that's actually repeating. So 1 over 3 would become 0.3 repeating. So again, as you say it, it's 0.3 repeating is how you say it. All right, I want you to try this one. So pause the recording and give this one a try. Okay, so we do the same thing we did before. We have 2 over 11. To get 2 over 11 into a fraction form, you take and you go 2 divided by 11. Now when you do that on your calculator, you're going to get 0.2 1, 8, 1, 8, 1, 8, 1, 8. And you'll notice that the part that's repeating is the, oh sorry, it's supposed to be a 1 right here, is the 1, 8. Okay, so you're going to put the bar over the 1, 8 portion. So the decimal equivalent is 0.18 with the bar over it. Now I want to give you a little bit of a caution here. Don't be sloppy when you're putting the bar up. If you do put a bar like this, the meaning to put it only the 18, but it includes the 1, what you're actually writing is this. Because you're saying that the 181 is the period that repeats. So be careful. It only goes over the digits that you want to repeat. And of course, how do we say this? This is 0, I guess I should write it, 0. Now in this case, you could say 1, 8 repeating, or you can go 18 repeating. Like that. So if you're talking to somebody and they say, what'd you get? You say 0.18 repeating or 0.18 repeating. Here's another one. Pause the recording and try this one. All right, so now we have 7 over 9 is the fraction we're given. 7 divided by 9 gives you 0.777. It goes on and on and on. The period is the 7, so the decimal equivalent is going to be 0.7. The 7 is repeating, and that's all you have to write down. So this is set as 0.7 repeating. Now, I've been asked if this is 77777, how do we know it's not 0.77 repeating? Like that. Or 0.777 repeating. Well, the problem with that is the definition of the period is the digit that repeats. And if you look at this, the digit that's repeating in every case is a 7. So you're not going to be including 77. You won't go 777. It's going to be just 0.7 with the bar just over the single 7. Okay, so what happens when you do mixed fractions? Well, mixed fractions are not that difficult because you're not going to use the whole number. Because it asks you for the fraction to be converted into 3/4, and this is the fraction portion of the mixed number. So all you really have to do is ignore the 1 for the first part and just change the 3/4 into a decimal. So this becomes 3 divided by 4, which is 0.75. Now take that number and put the whole number that we had originally with it, and here's our 0.75. You put them together, you get 1.75. So this is a mixed decimal. This is a mixed fraction, which kind of makes sense. All right, you try this one. Okay, so again, we're going to ignore the 12 to begin with and just first convert the 5 over 18. So 5 divided by 18 is 0.27777, like that. So the period actually is going to be this part right here, the 7. So the decimal equivalent is 0.27 with the bar just over the 7. Don't include the 2 because the 2 is not repeating. It's not 272727. It's just 7777. Now put in or include the 12. So it gives you 12.27 repeating there. All right, so actually it's 12.2 with 7 repeating. So this is set as, I'm going to put it in number form, 12.2 with 7 repeating. Now, originally I just said 12.27 repeating. You got to be careful because is 27 repeating this, or is it this? You got to be very clear with it. So that's why I corrected myself and said it's 12.2 with the repeating portion right there. All right, 4.89. You try that one. Okay, again, take the 8/9, and that becomes 8 divided by 9, which is 0.8888 on your calculator. Fills the screen. Now your calculator at the very end, the last digit, might show a 9. Don't be fooled by that. All your calculator is doing is rounding off the last digit for you. So don't include that and think that, oh, I guess it doesn't repeat because it changes to a 9 at the end. You don't usually include or count the last digit on your calculator because it can be misleading. The period in this one obviously is the 8. So the decimal equivalent is 0.8 repeating. Now add in the whole number. That gives you 4.8. And of course this is set as 4.8 repeating. Now, because there's only the 8 there, I can just say 8 repeating. Sometimes the decimal equivalents do not repeat or end. When this happens, we are going to round the decimal to the nearest hundredth. Now we haven't taken significant digits yet. That'll happen later on in your high school. So we have to have a very simple rule to start with. So we're going to do that, and our rule is going to be when you're not told, you round to 2 decimal places. So let's take a look at 2 and 13. So over 1,357. Okay, so when you divide this, you're going to get 2 divided by 1,357, which is equal to 0.001473894. All right. Now the problem with this is, if we round this one off just to 2 decimal places right here, my number becomes 0, doesn't it? 0.00. Well, we can't round something to nothing because that would affect our calculations. So in situations where you have leading zeros like this, you're going to go over and you're going to count the non-zero digits in your rounding. Don't include the first zeros. So what happens is, this is my cutoff here. This is my first digit, my second digit in my decimal. It's not to the hundredths, but it's the 2 decimal places or 2 non-zero decimal places. So this becomes 7 causes this 4 to go up. So my final answer is going to be 0. I guess I should put over here. 0014. Now if I did something, another one that had like 0.362497, then your cutoff would just be right here, first 2 non-zeros, and that's going to give me 0.36. Let's try the next one. 3 over 54678. Try that one and see how you do. All right, so obviously our first step is to divide it out. Okay. Now because I have such a large denominator, it means I'm going to have a lot of leading zeros. So I've actually got 1, 2, 3, 4 leading zeros with a 5, 4, 8, 6, 6, 6, 7, 3, da da da. So again, you go to the first 2 non-zeros, that's your cutoff. And of course the 8 causes the 4 to go up. So we have 0.123454. So there's your answer. Okay, so we've done really large fractions, so really small fractions. We've rounded to the nearest hundredth if not told, or to the nearest 2 non-zero digits. So let's go on to the next part. These are big fractions. So since fractions can also be improper, we have to work with these too. So here's your first example, 25 over 4. So I'd like you to convert that into a decimal place using the same process we just did. All right, so we have 25, the numerator, divided by the denominator. Don't be fooled into thinking it's always the smallest number divided by the largest, because that will give you the decimal equivalent of 4 over 25. We have 25 over 4. So 25 divided by 4 gives us 6.25. No rounding required. Here's your next one. 124 over 5. Do that one, please. All right. The pause button works well. 124 divided by 5. Show me what you did, and you'll get 24.8 as your answer. And then the last one. 38 over 3. Try that one. All right, so 38 divided by 3 gives you 12.6666666. So it just goes on forever. So we have 12.6 with the bar over the 6, 12.6 repeating. If you rounded this off to the nearest hundredth and went 12.67, I suppose that's correct because you weren't told what to round to, but it's always wiser to give the more correct answer. This is more correct than this. All right. Moving on then. How do we reduce a fraction? Well, to reduce a fraction, you have to find a common denominator of both the numerator, which is the 24 in this case, and the denominator, which is on the bottom. And you want to divide this by the factor or the number that goes into both. Now, if you know that a larger number will go into both 24 and 72, use that right away. And of course, you'll shorten up the amount of times you have to do this. But our goal is to get down to a point where we don't have any number that will go into the numerator and the denominator except for the number 1. When you're at that point, you stop. So in this case, you'll notice that they're both even, the 4 and the 2. So I can divide by 2 because they're both even. 24 divided by 2 is 12. 72 divided by 7 is 36. Now 12 and 36 are still even, so I'm just going to divide by 2 again. 12 divided by 2 is 6, and 36 divided by 2 is 18. All right, they're still even, so I'm just going to do it again. 6 divided by 2 is 3, and 18 divided by 2 is 9. And notice 3 goes into both, so 3 divided by 3 is 1, and 12 divided by 3 is, 9 divided by 3 is 3. So there is shortcuts. For example, if you take a look at 24 over 72, you may notice that in this case, 12 goes into both of them. So if you divide this by 12 and divide this by 12, this becomes 2 over 6, which then you can just divide by 2, and that'll give you 1/3. If you notice that 24 goes into 72 3 times, you could do 24 over 72 in one step. Divide both by 24. That gives you 1/3 right off the bat. All right. Now I'm going to ask you to be able to do this manually without a calculator. During calculations, in our fraction stuff, you know that you can use your calculator to actually reduce it normally, or sorry, with the aid of technology. So if I ask you, you have to be able to do it. Okay, converting decimals to fractions. So we know that if you take a look at this box here, I know that 2 out of 4 is shaded, and that's 1/2. And I know that 1/2 is another way of writing 0.5 or 50%. So you can use these little facts to help you make sure you get the right answer and develop the process. If you can figure out how to get from 0.5 to 1/2, just apply the same steps to the fraction to the decimal that you're given. All right, so there's 2 ways of looking at this. The first one is you can say 0.5 is another way of writing 5/10. Well, if 5/10 is what 0.5 is, then you can just come down here and go 5/10, and then you reduce it and you're done. The other way of looking at it, if you can't say it that way, is to look at the 0.5 and figure what place value is the 5 in. In this case, it's in the 10th place. So this becomes your denominator, and your decimal becomes your numerator. And then you can reduce it to get 1/2. There is another way of doing it, which a lot of students like. Take a look at this. You put a line under it. You put the 1 right before the 0, and then you add a 0 for every digit that's after the decimal. You'll notice that becomes 10, and then you ignore this part. So if I had 0.34, I would have the 1 under the 0, and I have 2 digits, so I put 2 zeros. A lot of students like to do that too. You must come up with the 34 over 100. You must come up with the 5 over 10, because that proves to me that you know how to do it. Of course, the dividing, the reducing, you already know how to do. So we know from general knowledge that's we're correct because actually 0.5 is 1/2 on our example here. So let's take a look at the next one. What happens if we have 0.25? Well, the first part would say this is another way of writing 25 hundredths. All right, so that would mean 25 hundredths would just look like this. If that doesn't make sense to you, you can look at the last digit of the number, and the 5 is in the hundreds place. So you can use that as a denominator, and that means that your denominator is going to be 100. All right. The decimal part becomes the numerator, so your numerator here is 25. So there are your two parts right there. All right. If you want to try it the other way, put the 1 under the 0, and the zeros underneath that, put a line there, and then just ignore this part. That gets you the 25 over 100 also. Well, now that you have 25 over 100, the next step is to reduce it, and you divide both of these by 25, and that gives you 1/4. All right, let's take a look at this one here. Converting 0.125 to a fraction, you look at the last digit. In this case, the 5 is in the thousandths place. That means my denominator is going to be 1,000, and the numerator is the decimal portion, so that's 125. So write this and reduce it. So I'm going to be expecting 0.125 to become 125 over 1,000. And then, of course, you have to reduce it. You can divide both of these by, well, let's just do 125. I know that's going to work. Divide both by 125, and you're going to get 1/8. All right. Got to catch up my notes here so I don't go too far. All right, so reducing the fraction gives you 1/8. So our next step is what happens when you have a decimal. You want to convert into a fraction that has a whole number. Well, just like we did fractions which are mixed with a number and a fraction and convert it into a decimal, we're going to do the same thing when we go back. You're going to ignore the 3.65, you're going to ignore the 3, and just work with 0.65. The 3 will be added at the end, so I need to take 0.65 and convert that into a fraction, and I'll let you do that right now, please. All right, so 100, so it's 65 over 100, and you can reduce this by dividing both of these by 5. 65 divided by 5 is 13, and 100 divided by 5 is 20. So you reduce this lowest form. I now have 13 over 20. But don't forget, we also had a 3 up here. That's got to be included. If you don't include it, I'm afraid we're going to have to mark it wrong. So the fraction here is going to be 3 and 13/25. All right, let's have you do this one, 34.2, completely. Pause the recording and complete it. All right, so again, ignore the 34. We have 0.2, so that's over 10. So we have 2 over 10. And that gives me, when I divide both by 2 and reduce it, I'm going to get 1/5. Now don't forget, there's a 34 that's got to come in here too. So I get 1/5 after I reduce it. Putting the 34 with the answer gives you 34 and 1/5. Okay, what if this was a very small decimal? But you take a look at it, it's exactly the same way as we did it before. You need to take and find out the position that the 5 is in, or put the 1 under the 0, and then put zeros under everything after the decimal. So I'm going to give you a second to try this. All right, so the best way to do this, so you don't mess up, is to do this. 2, 3, 4, 5. We've got 4 zeros and a 5. If you want to, this is tenths, hundredths, thousands, 10,000s, 100,000s. So that would be 100,000 in the denominator. Another way to do it would be this. Notice that put a 0 for every digit after the decimal place. So notice 1, 2, 3, 4, 5 digit zeros here, and over here I had 1, 2, 3, 4, 5. So both methods will work. Now take the decimal portion, or up top, the digit, which is the 5, and you put it on top. Now obviously anything that ends with a 5 or a 0 is divisible by 5, so we can divide this by 5 and divide this by 5, and you will get 1 over 20,000. Okay, try the last one, 0.0035. All right, we're back. So again, I'm just going to do this the short way. So I've got 1, 2, 3, 4 digits there. So I've got 1, 2, 3, 4 digits there. Sorry, 4 zeros there. So my answer starts out as 10,000 on the bottom and 35 on the top. Now again, anything that ends in a 5 or a 0 is divisible by 5, and that will give us 7 over 2,000. And there's your final answer. Now at this point, I'm going to stop. Not going to go any further. We're going to start you on your assignment. The assignment's on page 239, and I will select the questions for you in class. So we're going to stop the lesson here and have only half of this lesson due to its length. I find that I do everything in one long shot. It's too confusing. Okay, so we'll see you in the next lesson. If you have any difficulty with any of this stuff, please go back and watch it over and over and over again until you can do it without any difficulty.